Alright, here we are, back with our closing concepts. Let's look at an idea of that applies to functions, and that is, what is a one-to-one function? This will apply to inverse functions. One-to-one function, and I think we have met it earlier this year briefly, and all that means is if we have a graph that's a function, and say it looks like that. Obviously, if I say it's a function, it passes the vertical line test, indicating no x value has more than one y value assigned to it. So, and if I do it the other way, do the horizontal line test, does this graph pass as well? So this is saying for every y value, there's no more than one x value that's assigned to it. And you can see it does pass both ways. It crosses this graph at no more than one point going from either direction. When that's the case, we call it one-to-one, a one-to-one function. So let's look at another one and see if it's one-to-one. We'll take the squaring function, the smiler, and we see that it is a function. It crosses the vertical line test. But notice here and here it crosses at more than one point on the horizontal line test, so therefore it fails as a one-to-one function. So the squaring function is a function, but it's not a one-to-one function. So what's that have to do with inverse functions? It turns out that an inverse function, when you have an expression and you've come up with its inverse, the inverse is a function also if you start with a one-to-one function. So a one-to-one function, its inverse will also be a function. Now the other, if it's not a one-to-one function, it may have an inverse that you can find, but that inverse will not be a function. So let's see graphically if you can see why that is true. You can erase some of these extra lines. I'll show you the flip across x equals y line. So I'll show you two inverses, and you can see how one's a function and one isn't. So here we have the cubic function. So the wobble, we called it. So when you can see it passes the vertical line test. So now I'm going to show you its inverse function by flipping it across the y equals x line. So if I folded the board along this line, the imprint of the pink will look like this. Is that green also a function? Will it pass the vertical line test? It does. So because the red was it passed the vertical and horizontal line test, its inverse will pass the vertical line test for sure, for certain. All right, let's look at the squaring function again. And we already noted that it is not a one-to-one function, so we are expecting that its inverse is not a function. So let's look at the reflection of that across the line y equals x. When you fold the board along, this portion will stamp or appear along here. This portion will show up over here, and this portion will show up over here. So this red is the reflection of the orange. And the red, you can see, is the inverse, but it is not a function. It miserably fails the vertical line test. So again, the concept that I want you to come away with is if the function is one-to-one, its inverse is also a function. All right, the algebra will bring us to a close tonight. And it will look like this. We are going to take a function, and I'm going to show you the steps to write the inverse function. This will look familiar. All right. So f of x will start out even. We'll say y equals 5 minus 3x over 2. And I want to find the inverse function. Let's first of all rewrite, if we start with f of x, I want you to rewrite it as y. So it's easier to come up with the inverse function using x and y instead of using the equivalent f of x notation. So if it does start with f of x, change it to a y. Now the step probably will make sense now that you've seen the graph. We're going to exchange the x and the y. So wherever there was a y, we're now going to put an x, and wherever there was an x, we're going to put a y, as inverse functions flip x and y across the line. So next, I am going to take this expression and I'm going to solve it for the new y. So the new y is embedded in there, so I'm going to multiply both sides by x. By 2, creating a 2x, so I'm going to add a 3y, subtract a 2x, divide by 3. So the algebra gets us down to here. That's okay. Alright, so now, that's fine. Interruptions are welcome. Alright, so y equals 5 minus 2x over 3. What is it you're looking for?
Extended shortboard.
2. Alright, so y equals 5 minus 2x over 3, and that is the inverse function of the original. So we can test those algebraically, but for tonight, since I've already told you how to do that, I'm not going to take any more time. You would know to compose this, we would call this f of x, and we would call this g of x. And we would do f composed g of x. We would put this function inside of this one, and this function inside of that one. And we would find in both cases they come out to be x. But the grand finale is, when you have found the inverse function, y equals 5 minus 2x over 3, you are going to replace y with the notation for inverse. We were trying to find the inverse, say, of f of x in the beginning. We now use this notation, f inverse of x. Have you seen it before? With the little -1 up here. F inverse of x is at 5 minus 2x over 3. So the steps will be repetitious. You will take the original function, take it, use it, instead of f of x, you'll put y. You'll exchange x with y. You'll solve it for the new y and replace that y with f inverse notation. And sometimes I'll ask you to prove it that it really is the inverse function, and now you know how to do that as well. Alright, so all these skills should look familiar from the past, and we will practice them in class tomorrow. Bring me your comp book or your note paper with these notes on that so I can give you full credit for watching this video. Alright, have a good night or afternoon. Bye for now.